Good morning, everyone. So I'm Pongsak from Panasonic R&D Center, Singapore. For today, I think this morning from Prof. Salina and Matthew, I think started off a good presentation of RMF. So from Panasonic, even though we didn't start from day one of RMF, but we start from day two. Okay, to start to join some development, testing, and toward the deployment. So today I would like to share some of our learning that how we can contribute in some way for the deployment of the RMF. Just briefly explain about Panasonic. So we are many live business from the lifestyle, automotive, business, connect, industry, energy. So robot is one of our business area of Panasonic. So our we have evolved also when the world keeps changing. So we have evolved our brand slogan to now become live your best. That means we would like to continue our effort to make life simpler, safer, healthier, and more enjoyable, especially the effort to help our customer live their best. The focus is one is sustainability and the other is well-being. So for the robot is under the well-being, that how we can help our customer live their best. About some of the organization that actually also the reason why we didn't start from day one of the RMF. So we realized the importance of the ecosystem in Singapore. So we set up not just R&D. So our R&D, for myself, we are here in Singapore for more than 30 years, not just the robot, but we would like to support and contribute to Singapore and then attract some of the technology from Japan built in Singapore, for example. So we set up the center, also R&D, manufacturing, and also the sales and marketing together. So we join so that we can understand from the customer pain point, what we need to develop and what new technology that we need to improve. Okay. Yes, and we have a good ecosystem. Why we set up here is because we have NRP, and also partner agency including Chart, A-Star, EDB. Okay, we have many partner that working, and also research institute. Okay. And we have many friends in Singapore. ROS-I here, Open Robotics, and yes, we have others, many that we can work together in Singapore. So this is the reason why Panasonic, we are here in Singapore and want to work with ecosystem to speed up robot deployment. This is partial of our robotic area. HOSPI, as I think we already deployed at CGH for more than 8 years. Okay. This version, we have a newer one, but Serena says still very well, working well. So then we cannot have this, the new one. So yes, but we still continue to support and we want to improve further. Yes, we will support the expansion. Yes. So yeah, this is a HOSPI. We have been doing this business for more than 10 years in Singapore, more than 8 years, and we have a wheelchair, autonomous wheelchair for the PMO that we call. We do have other business for the robotic we are developing with the support of the ecosystem here. So Yes, this HOSPI, actually the design is a human-centric design. Although the footprint is slightly big, I mean, if we compare the space in Singapore, but with the consideration of that, with this design, the safety for the human and the interaction with the human, I think this is the our consideration, and for the security also that need to tap with the card, authentication card, so that the right nurse can take the medicine. Our value proposition of our HOSPI, one is the high safety technology. So we get the world first ISO compliance for personal care robot. So this is the to prove that our design, our technology is safe for use in the public area. Then we have track record, and also with Singapore team and with the support of ecosystem, so we adapted RMF, and we are one of the empanel system integrator of RMF with CGH with Sharp. So for the safety point of view, we have done a lot of consideration and testing, including the sensor position, the deployment, and also behavior when we do the obstacle avoidance, whether static or dynamic. So we need to consider the human aspect. In Singapore, yes, we have been doing our support from 2014 with Changi General Hospital. We run so well without any major issue, still want to continue to use it. And last year, we also extend to SGH. For, this is the Gen 2 version. So CGH should expand Gen 2 version. Okay, so in terms of our capability and contribution to Singapore, we didn't start from day one, but we start from day 2 of the IMF. So we realized that it's important to work with the ecosystem so that can contribute to solving so-called the community issue, the pain point of the hospital. So we understand well what is needed in a hospital. We learn from Japan, learn from working with CGH. And okay, so we decided to work on the IMF, and we also convinced our counterpart in the other side, in Japan, to say that IMF is essential and we need to do fast. So we adapt our commercialized AMR. We also integrate with many type of device, and also integrating other people robot also, not just Panasonic. We didn't develop this part. We just some of the part we do our adapter, and we support. We work with also support open robotic to test some of the module, okay, to verify that it's working well as the early adopter. So we would like to contribute. Yes, we have a qualified as the SI, okay, and then now we started to work with many partners to do. Here we also have some demo that we integrated with ARTC facility, the lift and door of the hospital. We work with startup Synergy that provide wireless contactless charging, because this is also to solve the issue of the space in Singapore. And I think that problem statement makes sense. So if we have 10 robots, you have 10 charging stations, I think we don't have enough land to do that. So therefore, challenge this problem statement. So we also want to contribute in this testing. And yes, as we have been working with the hospital in Japan and in Singapore for a long time, so we understand what is needed for hospital delivery and how we can optimize it and which of the stage that we need automation. Doesn't mean every manual we can be replaced by automation. So we need to know which one that we can have the high return of ROI. So we do the study as Panasonic ourselves. We do the manufacturing, we do the factory, we have the optimization, we plan what process is optimized, which one can be done by robotic automation, which one should maintain manual. So that part we analyze. So with this, and we try to consider for the RMF what is needed for the RMF. So for the robot operation itself, so we need to set the direction facing destination. There are some limitations now that we do some hack or something, but I think we already communicated with our ecosystem that is needed for the improvement. So I think that is the part. And also the speed setting of different paths that we may need different speed. So that is some of the part. And also the task specific for the robot allocating some tasks. Because as a human being, sometimes we don't want everything to be autonomous. We need to make some decision. And I want my robot to deliver something at this time. So if we say, no, the system already allocated that task you cannot do, human will not be happy to say that. Okay, so we need to be able to support that. And okay, charging mode of at the charger location. I think this part is already trying to consider. Okay, and this is the configuration that we are trying. Now we also setting up here that okay. And there are some consideration about the map preparation also that because for the RMF, we want to have a unified map, but the robot, they want to know at once a time they use one of the floor of the map. So we need to handle that part. This is one of the, because originally our design, the robot, we didn't design the robot to work with many other people robot. As we design, as the manufacturing, the robot vendor, we take care of ourselves. But in the RMF concept, we need to think about other people. So yeah, we need to consider that. And yes, I think that we have the robotic expert in our team, so they can solve that issue. This is some of the demonstration in our office. So we don't have the actual lift and at our office, so we will do the simulation. Yeah, this. Thank you. Okay. So yes, this is the simulation showing the robot position, and this is the actual robot that become. So you can see that initially the HOSPI, we have the HOSPI, and then we have a PIMO. Original route is come to this side, but because wheelchair is blocked, so then it's able to change the path. So I think this is the one of the essential feature for the robot to communicate with each other, to try to avoid and able to do the operation in different dynamic situations. You can see the HOSPI will go to other route and then come to the lift. This is the it's a simulation. It's good that we have this simulation. Then we don't need, at the testing, we don't need to have the actual lift. So we do the test at our site. So this is important. Something happened, yeah? Okay. So this is important because not just the development. In order to do commercialization, development is one thing that we have our system ready, but we need to do a lot of testing and deployment. So with this simulation, we can do testing in our lab, and for the deployment, will be a shortened deployment time. I go to the next one. Yes, this is the what Selena already mentioned. We tested at Galen, shipping this testing. So HOSPI also joined. We put HOSPI signage, and this is another type of HOSPI. We can see that with this so-called environment that allow the robot to, as our robot provider, to test that and prove that it's working and it can be commercialized. So that will help for promote to other people that it really works. It's not just, open source can work. So that is what we want to say. So this is a map in the debug mode. We want to show that we also can change the map at different floor. So it's the robot or the lift through RMF, and then it's go up another level. It will go up to level 5.
Which version of ROS are you running?
Okay, which version? I think I have my team there. Which version of ROS? ROS 2. Yes. So that is one that we can change the map. And this is not changed yet. Okay, but never mind. Yes, this is at ARTC, but this is the earlier data. This is ARTC, so we connect with the lift. Call the lift. Open. So you also can see the live demo later in the later session.
Please enter the left. Please enter the left. Please enter the left.
We notice some of the consideration. In Japan or even in CGH, when the robot take lift, it's not allow human to go inside the lift, right? We are considering in this RMF situation, the robot and the human. We want to have interaction, and the robot and human should be able to take lift together. In that case, we also need to consider the safety aspect, the regulation, maybe BCA. We need to talk to BCA about the lift. The requirements, the robot and human take lift together. But for this time, because it's not general people, it's our people that we know how to handle, so we take together with that. Yes, and then the robot can open the door. You can see that the door is narrow. Our robot a bit fat, but we can go through. Yes, with the accuracy of the positioning and navigation.
We have reached our destination.
And then it's come here. So
Please enjoy the next part of your program.
okay, yes, thank you.
So now we have Q&A.
Yes.
Hello? Yeah. How do you deal with the elevators? So how do you basically make the elevator come for the robot, or do you need a person that basically calls the elevator?
The robot call, because we know the position of the robot. Right? The robot come to this position, this lift. So the robot call to RMF, and RMF call to the facility.
Okay, cool.
For the elevator, one thing I've noticed is like, you know, if I take the elevator, my cell phone signal will just kind of drop out. So I won't have, you know, 5G. I'll be in like a concrete, you know, shaft, and I won't have any connectivity. Does that hamper some of the issue with using the robots in the elevator for like calling, or know when the robot knows when to exit the elevator, if it's like waiting for network connectivity?
This is good question. Yeah. So when we design our autonomous system, okay, to answer this question, we have not tested a lot yet for this part. But when we design our system, so even the no connection, the robot itself should be able to operate safely in that environment. So that is our basic concept, whether the HOSPI or other robot of Panasonic. So that is the basic concept. If the robot understand the connectivity issue or abnormal behavior, so we have some action that the robot will go to some safe location and communicate with the command center. So that is one of the basic design. But for this RMF, we have to test out that scenario because there is the two-way communication, the robot and the RMF. Because RMF may have some behavior that the robot need to understand. So therefore, we need to work together for the test at this point.
It's good to have like the local backup behavior, so like it knows not to run someone over when it's being
Right.
blocked in the elevator. I'm just thinking like maybe it has a recovery strategy. You're like, I don't know what floor I'm in, but I probably should get off the elevator to like stop hogging it. And just like, that's looking at.
Okay, Matthew can take that.
Maybe I'll try to help on this one. So the recovery strategy for the robot is typically wait. Actually, don't get out, but just wait until you have a signal and you can confirm what floor you're on. But when you're doing a deployment for RMF, one of the important steps is a site survey, and so you have to check connectivity in the areas. The critical areas, like the elevator, is super important that you have a signal there. When you're going down the hallways, it doesn't really matter if it's constant communication, but when you need a new action, that's when it's most important. It's best if the robot itself or the system has a failover between LTE connection and Wi-Fi. But depending on the deployment, sometimes the site only wants contained communication on the Wi-Fi network, so you have to make sure you have Wi-Fi in those areas.
Maybe a follow-up to that, is there, if one of the robots falls off the RMF network, are there ways that the other surrounding robots can accommodate that? Like, you no longer identify the obstacle as whether a robot or just a generic, so that maybe changes your route planning. The robot's not aware to give you a heads up on the other elements of the network. I don't want to hijack you.
Thank you.
Test, okay. So yeah, if it loses communication, RMF doesn't know there's an obstacle necessarily. But in the task management system, you can set timeouts. So if a task isn't updated or there's a delay, then it alerts a human for help to check on what's going on. Also, there's a new sensor pipeline system. So you can use LiDAR or camera data if it's available in the facility to detect if there's an obstacle, like a dead robot, and feed that into the traffic system. So there's different ways to accomplish it.
Thank you. Maybe a question to you and maybe even to the community out there. Like, what do we see the roadmap for mobile robots on escalators?
Okay.
For stairs, yes, there are legged robots. AMRs can get on escalators technically, but there is a lot on the dynamics. So do you have any concepts or plans?
Yes, that is the good questions about that. Actually, we have not thought of the AMR taking the elevator. I mean the escalator. Escalator, yes. Now we do the elevator, but for the escalator, we have more concern about the safety design. So that's part. We still need to consider the necessity of that features, whether it's needed or not. Because yes, we can prove that we can do, but the value of that part we have not verified yet. So at the moment, we didn't consider that aspect. In the future, we may have the escalator for the robot, maybe, yes. But at the moment, we have not considered. Thank you. Okay, thank you.